Hello everyone, I'm Gagan Agarwal from Team Thunderbirds and I'm here to present to you our project, blockchain-based e-commerce warranty system using NFTs. So let's get started. As you can see in our proposed approach, we've broken down the project into four main systems: the Mintkart platform, the Flipkart platform, a centralized node server, and smart contracts on the Tezos blockchain network. Our platform offers services to three different types of users: customers, sellers, and customer services. Customers can use the Flipkart platform to order products and also gain digital NFTs for each of their products. Sellers can use the Mintkart platform to batch mint their products as NFTs, and customer services can use Mintkart platform to check a product's existing warranty and burn an product warranty NFT in case it has expired. As for the tech stack of the project, we've used React for the front end, Node.js for the backend, MongoDB as our NoSQL database, Tezos blockchain for our smart contracts, and we've also used Twilio to send text messages to customers. So now let me take you through the flow of the Mintkart platform. So this is our Mintkart platform. We can head over to the sign up section. Here we can register either as a seller or a customer service agent. Here is a drop down where you can select the option of seller or customer service. We can quickly register. This will add the seller to our smart contract as well as our backend. As you can see, the seller has been logged in. We can head over to mint NFTs. Here we can mint warranty NFTs. To do that, we can add serial numbers of the products that we've already listed on the Flipkart platform via the Flipkart app. So we can gather the serial numbers from our notepad. Here I'll be adding the serial number. You can click on the plus icon and the product is added to the minting queue. For batch mint purposes, we've also provided the functionality to add serial numbers separated by spaces. So let's do that. Let's click on the plus icon and it will add the two products to the minting queue. We can click on any particular product and we can see the details of the product. These details are also fetched from the Flipkart platform. The same details will be shown on the Flipkart platform regarding the product. We can head back to our minting queue. As you can see, there is a wallet icon here in the navbar. This basically represents a custodial wallet that was generated for the seller to handle gasless transactions. So let's mint the items. We can confirm our password. Once the NFTs are minted, an NFT ID will be generated for each product. Now that the NFTs have been minted successfully, we can head over to the Flipkart portal where the buyer can purchase these products and gain a digital version of their products as NFTs. So this is our Flipkart platform for the buyer. Let's head over to the register page to create an account for a buyer. We can choose a profile picture and sign up. As you can see, the user has been logged in. We can head over to the My Profile section to check out the details that we've just filled in. Here we can also find a wallet section. This is basically the custodial wallet we've just created for the user to enable gasless transactions. Let's head back to the main page. Here, let's click on a set and the products will be fetched. We also have filters here, the price filters. We have also categories like electronics and fashion. We can also sort by ratings. We also have a search bar to search for a particular product. Now let's buy a product. Let's say I want to buy this shirt. We can head to the product page. As you can see, there's all the options here, such as the wish list option. You can add to the wish list. You can also add a review. As you can see, the review is added. So now I can choose to buy the product. This is the default address that we filled in. We can also fill in the actual details. We can continue here. We can see the total amount here. For now, the payment has been disabled, but we can enable that later on. As you can see, the transaction was successful and the order was created. So as you can see, this is the message that is received by the user when they purchase the product and receive a digital version of the product as an NFT. This message is received via Twilio. Now, as we've created an NFT for this product on our Mintkart platform, when we click on this order, we'll be seeing an NFT here. As you can see, an NFT has been generated for this particular product. There's an NFT ID and an NFT type. So we've created 4 different types of NFTs. You can head over to the My Profile section to the My NFT collection. Here you can see 4 different types of NFTs: a bronze ape, silver ape, gold ape, and a diamond ape. Basically, these NFTs have been classified based on the product you buy. And depending on the amount of NFTs you own, you can claim offers to purchase further from Flipkart. So let's head back to my orders page. Here you can see our product. So let's say our product turns out to be faulty and we contact the customer service. Now the customer service can use our Mintkart platform to check whether our product is within warranty and whether it can be replaced. So let's head back to the Mintkart platform. And we're back at the Mintkart portal. Here we can register as customer service. So let's do that. Select customer service here and click on register. As you can see, we are now logged in. We can head over to the check warranty section. You have to input the email address of the user who has requested for the replacement. Let's put that in. And we have to put in the product serial number, which you can fetch from our products.txt. As you can see, the product is still in warranty, so we can issue a replacement. Just confirm a password again and click on update product. As you can see, the details have been updated successfully. We can click on check again. And as you can see, there's an old serial number and a new serial number and the date. We can head back to the dashboard. Now let's head over to the burn NFTs part. As you can see, currently there are no NFTs to burn. And as soon as a product warranty NFT expires, we can choose to burn that NFT. So that was the demo of the Mintkart platform and the Flipkart platform. Now my teammate Harsha will be describing the smart contracts on the Tezos blockchain.
Hello everyone. In the next coming few minutes, I'll be giving a brief walkthrough of a smart contracts. I'll be covering how we have developed the custodial wallets, the gas relays, which enable gasless transactions for sellers, customer service, and also the Flipkart users. And also the features we have covered in the smart contract, security aspects we have covered, and also the gamification possibilities we have. We have considered Tezos blockchain for this due to the wide range of features it provides for making custodial wallets. It provides in-memory sign-up for development purposes to store, retrieve, and use private keys of wallet. To make transactions via backend frameworks, removing the overhead of installing, setting up the wallet extensions to sign the transaction, which we typically have in every blockchain. They also provide remote signers that can HSM bags for production purposes. So this would be a safer side of storing the private keys. But since it's only for development purposes, we have used the in-memory signers which the Tezos blockchain provides. So for every user who comes into our Mintkart portal, so when I refer to user, it can either be a seller or it can also be a customer service. So for now, we will assume there's a seller who comes into a portal. So when a seller comes into a portal and registers himself as a seller, we will be also creating a Tezos wallet for him in the backend automatically. So when I say creating Tezos wallet in the backend, it consists of creating two things: public key hash and also the private key. Public key hash usually refers to the wallet address which we usually refer to in every blockchain, and the private key is the unique identifier of that public key hash. So we have public key hash and the private key for given user that will be automatically created in the backend. Now there are like two things. First thing is the first security aspect involved is to store the private key and also to retrieve the private key to sign the transactions in the backend. And the second thing is to have some airdrop currency into the public key hash account so that using the private key we can make the transactions, we can sign the transactions which help as a gas payments. So coming to the first aspect, we have the following in our backend being implemented. So for storing the private keys, we have implemented a two level of security features. The first level consists of AES encryption, and the second level consists of using SHA-256 hash encryption. So coming to first, so to store the user private key, we'll be taking the user password and then we'll be AES encrypting it with the user private key and to get an encoded private key. So we can directly store this encoded private key. Now again to retrieve the encoded private key, we'll be again asking the user password. We'll be AES decrypting this time the encoded private key and then hence getting the user private key. So now we have got a flow where we can ask the user for his password and retrieve his private key and then sign any of the transaction on behalf of him. But this system fails if some attacker gets access to our encoded private keys. We'll be making an irreversible hash. So we'll be using the SHA-256 hash. So we'll be hashing the user password and admin private key, which is stored in the remote signers, which has some bags, and that is being provided by the Tezos ecosystem. So assuming that admin private key cannot be stolen, and then we'll be using the admin private key to hash the user password. And now we have got access to the Tezos wallet of the user in the backend, so we can assign any of the transactions which the user is providing to us via request. So we have also built the gas relays in our backend, which enable this particular flow, enabling the users to take their transactions via gas relays to enable the gasless transactions even. So let me quickly. So this covers how we are gonna assign each user a custodial wallet, which we call in the technical terms, to any given user who comes into a Mintkart portal. So given the user is registered into a Mintkart portal, we have a Tezos wallet ready for him to use, which also take care of retrieving the private keys, handles all the other overhead which we usually get, and also the gas payments. So let me quickly skim through the smart contracts which I have developed. So the code for the same could also be found in the GitHub repo. We'll be sharing out this link. I'll be just going through the smart contracts. So we have got error messages initially. Then we have the type setups for each of the definitions we have in the contracts. So we can neglect this for now. So to give a brief overview, we have built two smart contracts. The one is Mintkart FA2 smart contract. And if you quickly go below, we will be getting the other smart contract, which is called Mintkart. So the first contract is Mintkart FA2, and the second contract is Mintkart. So FA2 is just a token standard for NFTs in the Tezos blockchain. So this particular smart contract contains entry points, which we say technically in the Tezos blockchain, which refer to the definitions which we usually have in other blockchains. So in the Mintkart FA2, we'll be implementing the FA2 protocol to enable the NFT transaction. So this consists of minting an NFT and then transferring of the NFT, and also it also provides some helper functions such as replacing item, burning the NFT in technical terms, and etc. etc. So when it comes to Mintkart smart contract, the other contract, this will be consisting of entry points to buy any particular item and then to get the NFT. So right now we are talking about the warrant NFT in our entire flow. So users will be able to claim their warrant NFT through these entry points. So for this, we have used the other contract called Mintkart. So Mintkart consists of buy and then replace item entry points, and then also to burn the a given particular NFT. So these two contracts are kind of interlinked. So if I take some examples, so if I say replace item, init replace item to be specific, so we'll be getting the call to init replace item. It will be verifying, making few checks here, and then it will be calling out the Mintkart, which is the other smart contract we have, and then we'll be calling out the replace item entry point that's present in the Mintkart contract. Then the Mintkart contract takes care of everything. So it have its own definition of what should we do when someone calls the request item. So this kind of two level of contracts provides us with additional security features, which we have documented well. So for any of those purposes, please feel free to refer to our docs.